Hello, welcome on my channel. Today I will be doing the third part of the uncoupler series videos. I want to talk about the schematic and why I do it the way I do it. So let's get to the schematic. First I want to talk about the parts I used beside the locomotive decoder. So the extra things I used. I only have two examples, and that is for one. This is an Arduino Pro Mini Nano, and it's a Atmel chip, crystal, reset button and some power regulation for 5 volts. This is a 5 volt version and it works at 16 megahertz. This pin here, these pins here are the programming port, because this device doesn't have a USB connection. So there's nothing on the bottom, as you can see, and this is all here mounted. I bought this from eBay, from a company called Alice, and I will put a link in the description down below. They come in a package like this, and as you can see, the parts are there for you to solder on yourself. A few pin headers and a 90-degree pin header for the programming. What I also programming, I've made this one, and this is my programmer. It's a USB program to serial programmer, and it also came from Alice on eBay. The other part I used also comes doesn't come from Alice, came also from eBay, but and this is the tiny buck converter. You can Google that, or you can search on that on eBay, and you will find it there. You might have noticed the background, and it's a drawing, one of my most best ones ever, maybe. And on this drawing I made a little bit of a sketch about how it all operates and how I have connected it, how I have connected my Arduino to my decoder. First, a little bit of decoder, how it works. I will place it more like this so that you can see. Basically, this is the decoder here, and it has a microprocessor, and I know some of the lens ones have an Atmel chip on there. So basically it's an Arduino. Only it runs, of course, different software, and I don't know how to get it off, and probably it's protected with a read stuff and this and that. So how does this work, a decoder, and why I'm doing this? I got a remark on a forum where I'm on, and the question was why, and it was in a video I made about my failing of the decoder. I ruined the decoder while I was working on it, and thinking of it, I found out that I probably have pushed too hard on the decoder while it was in operation, and I made contact to the LED counterweight on the bottom where it was stuck to with double-sided tape. So I shorted it out and it didn't work anymore. I did have the power coming from there. I had the U plus and the ground. I had this power I had on the board, but the processor wasn't sending or receiving any signals. I couldn't do anything. The outputs stayed dead. So basically I ruined something there. But how does a decoder work? Basically you have the track power, the DCC track power. It's some of it alternating current comes into the decoder board here. Now there's a bridge rectifier in there, and some of them may have a little bit different system, but it's always the same. It's getting rectified. From there it goes to your common connector on your circuit board, on your decoder. This is the common positive to where all your lights are connected. The positive wires of the lights are connected, whilst the negative are all connected to the outputs. We come to that in a moment. It also goes to another little power supply, a voltage regulator, which controls it down to a 5 or maybe 3.3 volt. I don't know exactly what voltage there is. I think 5 volts. And they convert it down to 5 volts for your microprocessor, because that works on a 5 volt logic level. And basically that's all is happening. So you have a 5 volts rail on your decoder. You never get to that because you don't need to use that. And you have your U plus connector wire going here. And that's hooked, that is your common for your lights. Now the ground wire, and this is why I had this question, why don't use optocouplers and make them switch to your Arduino? Well, I didn't want to use them because more electronic parts, and I didn't want to do it because I thought the ground, and that's where I was right, luckily, the ground wire goes, the ground of your circuit board goes to the processor directly via this power supply. It also goes to the ground input or output of your decoder. This is for maybe your power cap that will give you power when you're getting in a rough patch of track, dirty piece of track. This ground also goes to your processor here, and it goes also to the output system of your decoder, because your decoder, as you might have noticed, the ground's getting switched by a little device called a MOSFET. And this MOSFET gets this +5 signal coming from your processor, and it goes into the MOSFET and it switches this output to the ground. And that's where I got my idea from. The signal, by the way, and this is what you see here, here is the signal coming in for the DCC signal. The track signal comes in here. There's a little filter, and that is where your decoder processor talks to your central processing DCC station, or your DCC station talks to it. It receives and transmits its signals here. Also, there are a few wires going to the motor driver, and probably that runs with MOSFETs as well. And they give in a speed and a directional signal, and then it will go to your motor. But let's go back to the ground. The ground is here, and I hooked my system, which I made, also up to the ground and U+. So here is about 24 volts, 22 volts, and it goes down to my buck converter, which makes a positive 5 volts, which I send directly into the Arduino, which has a little regulator still built in, and it keeps it on 5 volts. But the ground, as you can see, is one continuous loop. it goes all the way here. Also, the 5 volts is going to the servo, which is up here. It needs also 5 volts. The ground from this servo comes from here and goes there. The signal wire comes from the Arduino. In the Arduino, and I will be giving the sketch I made for it, I'll copy and paste it into the comments, into the description down below. The inputs I have programmed as inputs that are using the internal pull-up resistor inside your Atmel chip on board here. Inside this little block there are pull-up resistors, and you can program them using the program to pull up this input here to positive 5 volts. They are always high. As soon as I switch my output on the decoder on, this MOSFET switches, this one becomes negative. And it will pull this input of the Arduino to ground, low in the programming language, and then it will send the servo in one of 2 directions, or it will, you can do something else with it if you want to. Same goes here. And because of this thing, I can do this, and it's only possible because my ground is always the same. The ground I've just daisy chained all the way through here. The ground also goes to there, and that is why the servo doesn't fry or anything. It just gets its 5 volt. If this was a servo that would require 12 volts, I could make another, could have taken another buck converter or taken LM 7812 voltage regulator and put it in here, and the ground of it to here, and the 12 volt outs to here. That would still work, and I could drive it with the 5 volt signal coming from the Arduino, because the ground is your common wire and it goes everywhere inside the decoder. It's hooked up to the processor, it's hooked up to the buck converter, it's hooked up here in the Arduino, in the microprocessor of the Arduino as well, and it's hooked up to the servo controller here inside the servo as well. On the top I've drawn the little thing of the forward and reverse lights, and these are also controlled here by the processor. And that is why, and that is how I have connected it, and that is why I can control my Arduino with the output pins of my decoder. Now you really should check that your outputs of your decoder, I don't know if every brand does it, but some of them might use a transistor here which pulls this to the positive, and you have the common ground. This will only, what I did, will only work if in this direct fashion, will only work if your decoder has a common positive connection. If it has a common ground connection, then you cannot do that, and you need to use optocouplers or reed relays or something else, or resistors. Maybe you can, don't know if that's a good idea, by the way. Scrap that. So that is why I can do that only on decoders with a common positive connection. I could have hooked this buck converter also to one of the outputs so that I could have turned it on. but then I had to not put this wire to the output because then it wouldn't work. I had to put this wire over there and then I could switch it on and off. But I've driven it for a little time and nothing heats up and everything is okay, servo's working. So there you have it. This is why I did it. If you have any questions about this, please put them in the description below. If there are, I post this on the internet forum as well, where I'm a member of. If anyone has questions there, then they asked it and they ask it a lot more. I will make another video. So if you have any questions, post them down below the video. And if you want, please subscribe to my channel. It will help me a little bit more in doing some more stuff. Like it, give it a thumbs up, as David Jones of the EV blog would say. And yeah, share it with everybody who you want to. So thank you for watching and goodbye.